Before starting my talk, I'd like to thank the organization committee giving a chance for us to introduction ourselves and talk about our research a little bit. My concept today will be about my previous research, which is related to DNA origami technology, and my current studies, which is also related to same purposes in biomedical applications. And in a small, if we narrow, vaccine delivery and gene therapy. And as a quick overview, I graduated from Istanbul Technical University in Molecular Biology and Genetics Department. My main focus area was related to neurodevelopment. And I went to University of Delaware in US. And I completed my master's degree in chemistry and biochemistry. And then I skipped to George Mason University to earn my PhD degree in bioengineering department. And my main focus area was also DNA nanotechnology, and I'm still continuing actually DNA nanotechnology field. I couldn't leave it. And basically, I want to mention just my main research, which is using DNA origami for vaccine design, but I wanted to show as well as a first step what I did first, like generating single-strand DNA scaffold, which is in DNA nanotechnology, people knows that it's hard to generate your own scaffold for the making our nanoparticle for different purposes, because main limitations regarding the scaffold production requiring extra steps of purification of modified staples and after the process of nanoparticle synthesis. And in the meantime, we achieved that protect the integrity and the yield of the nanoparticles after get rid of this requirement of the modified staples. And basically, I would say the significance of our work is we would achieve to make a direct modification of single-strand DNA scaffold for functionalization of the DNA origami nanoparticles, both random modification and precise modification on the scaffold strand. And later on, we continued using this scaffold strand for vaccine design. We modify the DNA, synthetic DNA, in three dimension and attach different molecules in this at the same time for simultaneous presentation in the cell. And in the thereby we can control the stoichiometry and valency in special organization by the advantage of the DNA itself, and after folding the structure into any geometrical shape and size. And also the benefits of this technique, you can track your structure in vitro and by controlling also the organization or modification of the structure. So I would say we generated DNA origami vaccine against SARS-CoV-2, and it's protected. In 15 days, we monitor the structure, and 15 days protection. There is no animal death or any changes overall. So my current project will be combined with DNA origami and also adeno-associated viruses. Sorry for my illiterates, because I'm not expert of the adeno-associated viruses. I'm just learning, and I came here for 15 days before. So basically, I would say adeno-associated viruses are practical for gene therapy, and those are lack of pathogenic and show low toxicity. But the main limitations regarding the use of adeno-associated viruses for gene therapy, it doesn't allow you to package more than 5,000 bases, which is challenging. And the main solution would be a co-transduction of the multiple vectors carrying multiple genome pieces. But in the meantime, you see that there are rate-limiting factors which you can't control during the cellular delivery or integration to the genome. So our solution is using DNA origami or DNA itself, linking multiple AAVs together and using DNA origami as or again, DNA itself as a molecular ruler or rigid linker. And in the meantime, we will be ensure that our nanoparticle or AAVs, origami particles, will simultaneously presented and integrated to the genome. So yeah. And what I like about my work as a researcher, I would say science is not separated from creativity. And probably the main driving force inside of me is as a human being, we are very tend to be creative, maybe, and it's coming from the gut. And there is no limit for us in the science, preventing us from imagination or creativity. And creativity, I would say, as a critical characteristic of the science. So what I expect from the Alliance and from this program, and which is actually a very, very recent paper. They mention about the intertwined of creativity and science together. And to maintain and grow creativity in scientific endeavors, you have to bring all scientists, I would say multidisciplinary or interdisciplinary settings together to be created and sustainable science. So what I like about the region, here, strong ecosystem already established. And other than this scientific environment, I would say historical texture also attracted me a lot here. And another thing might be the diversity, because I see like many international people, I can speak English very well because I don't know German. So another probably the benefit of being here or in this region. Thank you all, and yeah, I'm expecting your questions if you have.